So we are in our green section, oxyacetylene. Today we shift gears from the overall general safety training that we were going through with the drill press and grinder and all that good stuff that you use. And now we're getting very specific into your first type of weld. And there's obviously a lot of technical things that you have to understand how to set this equipment up properly, the safety that goes along with it. You're gonna spend a lot of time using this. Now this portable is only for your performance testing, and if I have overflow where I need to get someone extra on some equipment. Okay, so eventually when we get this place up and running, there'll be rotations going on. We'll have people arc welding, MIG and TIG, doing their creeper seat, doing the CNC, and then they'll be doing oxy. And that oxy is set up on the walls. All your regulators are on the wall, your hoses and everything there. Maybe you've been gone for a while and the booths are full that day and you need to do some catch up, and I decided it's better if we just do some oxy. We could wheel this out here and we could set up another station for you. Okay, so this one you don't normally see too often. It works really good for our performance test though, because we can have it out here in the shop with us. We're gonna have the toolbox project going on at the same time, so when you're ready to test, you can just walk over to me. We go through all the stuff that we're gonna talk about in the next couple days, and then we can get you through that performance test. So, if you remember, I told you there's 4 things you need in order to get started in this class. One was that open book machine test, which you're all done with now, say. Then we have our written test for the oxy equipment. That will look like a multiple choice, fill in the blank. I think there's maybe 8 questions that way. There's going to be an identification sheet that will have the equipment, and you will list what the parts are. And then there'll be a list of instructions on how to properly set the regulators, light the torch, and bring it all back down again. Okay, so that's what you'll provide to me with that performance test where you actually do it for real. That's a requirement in order to get started here along with your lab feed. So those are, we're knocking them out. Okay, we got one in the books already. By the end of next week, we should have another one in the books. And then shortly after that, your performance testing will start to happen. When the toolbox is going on, I'm going to leave this out. I'll probably put it off to the side somewhere. And at any time, you can take a break from working on your toolbox. You can come over to the tanks, either by yourself or hopefully maybe with another person or a couple people. And you're going to start walking yourself through the steps. Okay, how do I set the regulators? How do I light the torch? How do I take it back down again? The only thing that I won't have you do for real is actually light the torch, because you haven't been qualified to do that yet. But you can kind of go through the motions of what that would look like. Then if you feel like you've practiced and you know all the steps by heart and you can go through it, then you'd flag me down and tell me I'm ready to do my performance test. And I don't watch you go through all the steps because I don't need to. Okay, if you do a certain step wrong, I'm going to know whether or not I watched you or not. So what it would look like is you come to me, say I'm ready to performance test. I would check your regulators before you start to make sure they're at 0. I'd say go ahead and start. You're going to go through the motions, you're going to get the regulators set, you're going to get your torch ready, and then you're going to flag me down and say I'm ready to light the torch. I'd walk over, I'd see you light the torch, I'd see you adjust it to a neutral flame, I'd give you the thumbs up that it looks good, then I'd watch you take it back down again. Okay, once the flame has been extinguished, then I walk away, you put everything back down to 0 for the next person, you flag me back down, I check it, hopefully we cross you off. Okay. If you make a mistake either while you're lighting the flame or something with your regulators, I do try to give you a chance to redeem yourself during that process. I'm like, okay, you're close. And then maybe you have to take a step back and go, all right, what did I miss? And a lot of times you'll catch it, you'll fix it yourself, and then I can pass you. Okay. If you just can't find the mistake, then I will eventually have to tell you what it is, and then you'd have to redo the test. Okay? So that's why I want you to practice and have people with you so you can kind of walk yourselves through and catch each other if you're making mistakes. Any questions on the performance testing side of it? By doing that, you are displaying to me that you understand the correct procedure, because it isn't just as easy as you crack open some valves and you light a torch. There is a procedure of what needs to be done first, and then what's next, and so on and so on. And so we can't just go into, okay, I'm just going to start cracking some stuff open and see what happens. We're not in that environment anymore. Okay, this is pretty dangerous stuff. So But anyway, we'll cover that as we go through these notes. All right, well, let's start with the operator apparel. As you're in here working, we maybe have touched a bit on a few of these things just in general, when we started talking earlier in the week, but there are some things now specific to if you're going to suit up to do some welding. And let's be more specific today with oxyacetylene welding. So if I were to just go back there the way I am right now, I am not equipped to go do oxyacetylene welding. Okay, I got a good start, but I'm not all the way there. So let's take a few notes on the apparel. One would be your welding coats. This would be something that you'd want to wear while you're back there. These are cotton, 100%. They do end up getting ruined a little bit. Most of these are in pretty good shape, but I'll just show you the difference. This is a new one that I just opened up this morning. This one is at the end of its life, okay? Notice how we've got some tears. Looks like the sleeves are getting a little frayed on there. A couple little holes here and there, but this is what, your shirts and things would start to look like if you did wear a coat. Now, if you're wearing a cotton t-shirt, it's not flammable, this is what it would look like, okay? This is flammable. It's basically a plastic, so it's just gonna melt when it gets those sparks in it, or if I had a flame happen, it's gonna melt to myself, which doesn't sound like a very good time to me. So that's why we wanna wear the coats. A lot of you wear jeans, those are fine, okay? If you're wearing other things though, we have to look at, are you appropriately equipped to go back there to do that? And once we start the welding, again, that's gonna be right around that MEA break time, then you have to start seriously considering how you come to this class. Do you have the right footwear? Are you still trying to get by wearing shorts when you're trying to weld? That's not gonna work. So you may have to adjust some things, okay? I do have some people that will bring old shoes and just leave them in their locker, because they like to wear slides, and that's just, so I'm not forcing you to wear them all day long, but they don't work back there in this environment. I can't allow that to happen. It's just no different if I said, well, you don't want to, wear safety glasses. Okay, whatever. Okay, it's got to be done. And with flames and sparks and all the kind of stuff that you're going to find back there, even if you're not the person welding, those things are going on back there. So we have to be prepared for that. So welding coats are provided for you. If you have an old cotton flannel, you want to bring that in because you just want to have your own. That's fine, okay? As long as there's no other material in it. If it's 100% cotton, we're fine. If it's not frayed, we're fine. If you bring it in, it's got the little frays in it, that doesn't work, okay? And you can ask me those anytime. We've got time to prepare for that. So, next thing are your goggles. These aren't just regular goggles, these are Shade 5 goggles. On your test, it will ask you that. What will you need for eye protection for being in the booth doing oxyacetylene welding? And you're going to say?
Shade 5.
Shade 5 goggles and
Coat.
safety glasses. Okay, safety glasses always. Okay, safety glasses always, Shade 5 goggles if you're welding. Now this is where some people can get confused. They're like, well, wait a minute, if I've got the goggles on, then what's the deal with the glasses, right? Why do I have to keep flipping back and forth? The reason is we would forget probably after a while to flip back and forth. You would take your glasses off, you put your goggles on, then you take your goggles off, and you probably walk out and do something else, and now you don't have anything on. Okay, remember, no matter what, from the minute you walk in here till the minute you leave, the safety glasses are just a requirement. It doesn't matter even if you're sitting out here. And I get that, comment, well, I'm out here, I'm, doing whatever. It doesn't matter. Okay, wherever you're at in this shop, you have to have your safety glasses on. But you have to then double up if you're doing oxy, okay? Or if you're doing arc welding, then you have your helmet, but you still have your safety glasses on. Is it an inconvenience? Kind of, yes, it is. A lot of times when you pull your goggles off and your glasses want to come off with it, it is just part of the game, okay? You just got to get used to it and come up with a system that works for you. As I look around in here, I don't see anyone with prescription glasses, so that helps. Because guess what our prescription glasses people have to do? Safety glasses and, regular glasses, safety glasses, goggles. Okay, and they're just like stacked with stuff on their face. It is the requirement. There's no way around that. So, then other things along with operator apparel would be some things to look out for now. So pants with cuffs, frayed edges on your pants, pockets in your shirts, loose or baggy clothing. All these are great places for sparks to hide. And they may not do anything but make those little holes in your shirt, okay? Or they could smolder and become worse. Oxy, we don't throw a lot of sparks, okay? Every once in a while we'll pop and we'll get some sparks, but it's more arc welding, MIG welding, where you see the sparks and they'll get caught in those little areas, and then every once in a while you'll see someone dancing around because one found their way, in their shirt or something like that, or, shoes. We talked about that. Slides don't work. Running shoes aren't very good because they've got the vents and the holes and sparks go through it. And so again, if you wear those on a particular day, and I wear them, okay, I have to be more mindful than that day of what I'm doing, so that I don't have that problem. I was going to bring it in today. I have some shoes that have the holes in them from where I was doing some plasma cutting and, the sparks sprayed down and I'm dancing because now I forgot that, I have those kind of shoes on and my socks look like that, when I got home. They were all full of those little holes and so anyway, just look out for that. We had a case where we had some frayed edges on the bottom of some pants. They did start to smolder a little bit. It wasn't like they were on fire. Someone noticed it. They walked by with their welding gloves and they just tapped them a few times and it was out. It was no big deal. Okay, but we got to just be aware of those things because things can happen pretty quick. I share a story about a time in high school where we had a shop very similar to this size. A buddy of mine was working on his sled. Had it tipped on its side. I'm not even sure what he was welding on, but he was kind of in it. He was in his sled working on something. I don't know if it was belly pan or something he was tacking together. But anyway, he had that. He had the frayed edges on the bottom of his pants, and they started on fire. Literally, they were on fire. The shop was extremely disorganized. There was stuff everywhere, and again, that's why it's not just because I'm a neat freak. It's because we have to have a clean environment to work in. So now you've got this thing going on. He's inside his sled welding. He's got his helmet on. He's oblivious that this is happening. Okay, he's got work boots on, so he's not feeling it. Another buddy of mine notices this, and back there on the wall, we've got the fire extinguisher, right? Ours had that case around it with the glass. He punched it. He didn't even grab the little hammer thing. He just punched it, grabbed it, just, I can still see it. It's just that cloud of white stuff everywhere. And my buddy that's on the sled still doesn't know what's going on, right? He has no clue. And he figures this out, and he's cussing and swearing, and he's so ticked off, because he thought this guy was just being, his name was John, he's like, he's kind of a clown, he thought he was just being a jerk. His sled's covered in that foamy stuff, and then he finally calmed down, and they're like, dude, look at your pants, and they were all burned up, and he's like, wow, man. He had no clue, had absolutely no clue that his pants were on fire. Ironic, the Good Samaritan in this story, John, ends up going to the ER because he cut his fist all up from punching the glass. So the other guy's fine, he just got ruined pants, but the other guy got hurt. Also, John is now one of the volunteer fire department guys, so I guess he was kind of training already when he was in high school. But those things can possibly pop up, and you have to be aware of those things, that you got to act quickly on those. And if we could prevent those things from going back in the booth to begin with, then we shouldn't have those issues. Any question on the operator apparel things? Now again, some of you are going to be in a situation where maybe on a Friday or when basketball starts, if you're in basketball, you're asked to dress up, but now you're coming into a shop like this, and it can be, okay, what can I do today? I'm all dressed up and I don't want to leave here dirty, and And I try to work with you on those things. You know, most of the codes that we use are clean, you know, they're gonna get the outside of them dirty, the insides are clean, but if you're really concerned about it, you know, just come and talk to me and we'll work through that. All right, let's go down to fire prevention. Never use oil or grease on your equipment. This should be a no-brainer, right? In school, we don't have that problem. Outside of school, you could. Let's give you a scenario. You're working in your garage and let's say you're working on a four-wheeler or you're working on your truck and you've been working on it, right? You've been working on, you know, parts of it, you got some grease and dirt all over you, and then you realize, hey, I got a part I need to weld up today, and you start throwing sparks, and all of a sudden your pants are covered in oil or grease or something like that, and now you have yourself a problem. So, again, I'm trying to prepare you for more than just what you could find in this room. I didn't mention this yesterday, I think it was yesterday or the day before, we talked about the bandsaw stairs. Most of them come with a tank that you can put cutting fluid in. And that cutting fluid will go over the blade and cool the blade so that we don't have issues with it wearing out and it keeps the heat down. Same when you're drilling, you know, you can put an oil down so that it doesn't heat up. The problem in a classroom setting is that gets everywhere then. Okay, people aren't very careful with it, so they spill it on the floor, and now you got a slipping hazard, or they don't wipe it off completely. They take it back into a welding area, right? You got sparks flying all over the place, and now you got that fire hazard. So I've chosen not to include any of those cutting fluids or anything like that in a class because I don't want to deal with those issues that come along with it. We looked at where the fire extinguisher is. I could see why you'd be hesitant, right? Most of the time, you're like, I see them hanging there, but you never see them used. But this is an environment where that could happen. I mean, I would hope that in most areas of the building there wouldn't be fires. We make fire, like we purposely started up. And so with that environment, if you thought to yourself one day, let's say you walked through those doors and you saw something, like that case I showed you with, you know, my friend John. And you're like, oh my gosh, like, then do something about it, okay? I don't care if afterwards you're like, whoa, you kind of went overboard with the fire extinguisher, all right? All you had to do is maybe tap it out with the glove. At that point, we can talk about it, okay? But maybe it is bad, and then you gotta take some action. Don't be the person that goes, looks like it could get kind of bad back there. I don't know, maybe someone will step up and do something about that. Be that person. You know, all of us could be in that situation where time is gonna start ticking. We did have an old arc welder that, it was like a beast, okay? Most arc welders are like this. This was like on wheels. It was from the 70s. It was like a train cart. I mean, it was huge. Had all of these electronics and like wires and it was just this mess. And that thing started on fire one day. Okay, the bottom of it, we started seeing little flames shooting out of it. We didn't get to the point where we had to get the fire extinguisher, but it was pretty darn close, you know. Again, these gloves work perfect, you know, they're fire resistant, and the person by it just kind of tapped that area a few times, it put itself out, and there was no problem. But if no one stepped up, that can start to engulf pretty quick. So just be careful about that stuff. Checking for leaks. What if you smell gas? You're back there and you smell gas, and you're like, pretty sure I'm smelling gas back here. Well, there's a couple things that could be going on. One is someone has cracked their valve open, and especially when we start, that's why we go through this performance testing. They crack the valve open, gas is flowing out of here, and they can't find their striker. They're like, I had a striker here somewhere, and that whole time this gas is just blowing out of this thing, okay? You're gonna smell gas, right, when someone does that. You're gonna have a small smell of gas here and there when people crack open, you know, before they light. That's normal, but you shouldn't have a continual smell of gas. So does anybody know the trick to check for leaks if you think that you smell gas, whether it be on a torch or it could be your dryer at home? How do you check for leaks?
Soapy water.
Soapy water. It's that simple. You go grab some dish soap, you shake it up in a bottle, and you just pour it around that opening where you think there might be a leak. And on this, we could have a bunch of them. We've got connections here where the hose comes in, those can loosen up. We've got connections here. We've got the valve itself. We've got the connection where the welding tip is. If you think there's a leak, that's what we do, okay? Now in your booth, you're gonna have a shut-off valve that looks like those on the wall. Those are the main shut-off valves. There's a shut-off valve for each of your acetylene and oxygens for your own area. If you think there's a smell of gas, that's the first thing you do. You don't worry about, I wonder if there's something happening. Don't shut your valves off, okay? The people next to you need to shut their valves off too, because we don't know where it's coming from. I'll tell you the most common place that happens. It's right here, okay? Now I tighten these up and I check everything, but the problem that we run into is, imagine you've got second hour, third hour, seventh hour. I'm grabbing a torch, I'm using it. I'm grabbing a torch, I'm using it. I'm putting it here, I'm putting it there. This thing is where eventually some of these connections can come loose. And all of a sudden you start to smell that gas smell and you're like, I don't know what's going on. Then we don't take any chances, right? I have that soapy water available right away. We can check them, and usually we find that. If we can't locate the smell, then we gotta investigate deeper, okay? Because we can't run an area like that if we smell gas. It's just not very safe. If you go back there to use the booths and you can weld for a few minutes and then your gas runs out, it's probably because you didn't turn the valves on, okay? The main valves that supply you are turned off, and you'll know they're turned off because the valve is facing away from the pipe. So any shut-off valve that you see, that's an off valve, and when it's pointing with the pipe, it's on. So come out here and check that. If you come out here and they're on, then if you follow the pipes outside, that's where my tanks are. And chances are my tank dried up outside, and then we just have to change it. And it usually happens when it's about 20 below. So then I get to go out there and fumble around with tanks, and I hate being cold, and that's just life. But just come and tell me about that. And you'll know if it's a problem because everybody's looking at each other going, all right, what's going on here? If it's just you, then it's probably just your booth, and we'll have to investigate that a little bit. Also, along with fire prevention, I'll show you on another torch. Show you on this one. This one's a little easier. I want you to write this down for fire prevention. These are called flashback arresters. Flashback arresters. These are like check valves. They'll let the gas go one direction, but they won't let anything go back in the opposite direction. This is a good thing, because here's a scenario that could happen to you. You're welding, minding your own business, doing your thing, right? Maybe you've welded for a while that day. The end of this tip starts to get really hot. And when it gets really hot, eventually sometimes instead of allowing the gas to exit and become a flame, it actually burns the gas before it gets out of the tip. Okay, it's so hot that it's burning it inside here. Well, eventually, can you see how that would start to then burn back? And now the gas is, ignited, and it's just going to keep going to where tanks, right? Does that sound like a good time? Maybe to you, I don't know, but gas going through the lines and back into the tank sounds like a pretty bad day for me, okay? So these have been placed in here to prevent that from ever happening, okay? If there ever was a flame that started to shoot back into the torch, it would only get this far. And then the flashback arrestor would extinguish that, and then it would stop, okay? And no one's harmed and everything is good. Could you take these off and just hook a hose to the torch? Will it allow you to do that? Probably. Yes. Okay. And so I'm educating you. Yes, mine all have them. Could yours not? Possibly, right? That's what you have to pay attention for. So again, if I haven't said it enough times, I'm not just training you for in here. I'm trying to prep you for what do you see when you leave, because I can't control those environments. I will show you a picture on Monday, if you remind me, of the oxyacetylene tanks that are on our farm right now as we speak today. And you're just going to shake your head. And I've talked to my dad. I've tried to train him. He's untrainable, all right? He just doesn't want to listen to me. He leaves his outside. Why? Why would you leave this outside? Doesn't just leave it outside while he's working with it. He leaves it outside in the summer and in the winter. Makes no difference. That's where you find it, okay? I don't want anything to do with it, okay? And then he gets mad because the hose is cracked and everything's wrong with it. It's like, well, take care of your stuff, right? But that's the kind of equipment that I assume some of you are gonna come in contact with, is this garbage that no one took care of. And then you need to be the person that's educated and goes, that's not right. That's not right. If you ever wanna get involved in purchasing your own equipment, let's say you get to the point later in the semester, like, you know what, I wouldn't mind getting some of this. What does it cost? You know, where do I go to get it? I can easily sit down and do that with you, okay? So you can make some educated decisions. Stuff like this on oxyacetylene, I wouldn't get on Craigslist. I'd stay away from it, okay? You just never know what it's been through. It's like buying a jet ski on Craigslist. I would never buy one, because jet skis are fun. And probably whoever had it before you had a lot of fun with it. So, same kind of goes with this. You just don't know what they've been through, okay? So, but I can send you in the right direction if that's something you're interested in. If you ever hear a pop or a squeal, then that means that you probably had a little bit of that where it, blew the end, where it exploded on inside the torch, and then just shut your valves off and everything will be fine. Because your torch won't be, it won't have a flame anymore, but you're still letting gas out. So you want to turn those valves off. All right, let's go down to oxyacetylene welding and cutting equipment. Oxygen. We'll go through these kind of quick. Oxygen is not the fuel. But when combined with acetylene, it produces the heat. Okay? So oxygen is not the fuel. Acetylene is the fuel. Oxygen provides the heat. And when we go through the setup of your torch, we're going to look at not only your welding tip, but your cutting tip. And you'll see how drastically different the pressures are when you want to cut. Because you got to have a lot of heat when you're cutting. And I'm going to show you what those pressures are so that you know those things as you go through this class. Cylinder pressures between 2,000 and 2,600 psi for oxygen. Cylinder pressure is between 2,000 to 2,600 psi. What's a typical car tire? 30 to 40, right? 2,000 to 2,600. That's how much pressure is built up inside this tank when it's new. Okay, as you use it, of course, that pressure is going to decrease. Another note for your oxygen, that's a tall tank. Okay, your oxygen is going to be your tall tank. Acetylene is going to be the shorter one. You're going to see that oxyacetylene equipment is very visual. A lot of things that distinguish each other, so that if I walk up here, they don't make the acetylene tank and the oxygen tank the same exact height and shape for a reason. Because you can easily get confused. Which one's which? Okay? You'll notice there's different colors. Okay? That's all to help you through identifying what's what, so that you don't make mistakes. Because again, there are times where acetylene has to be first, oxygen has to be second. If you make a mistake on those two, you can have an issue. So, very visual when you look at that. Cylinder can explode if violently dropped or valve stem is broken. Cylinder can explode if violently dropped or valve stem is broken. Now I'm willing to bet, if I told you, let's take this tank outside, let's point it out in the field, and let's take a big old hammer and bust that valve off again, and let's see what happens. How many of you are going to join me on that little field trip? Right? Like, yeah, let's see what this thing will do, man. There's 2,600 psi inside this thing, let's go. This thing is going to be like a balloon that you filled as full as you can get it, and you just let go of it. Okay? So if this thing were to tip right now, okay, scenarios like this are easy to come by. This isn't something that you definitely have to create. Let's say we don't secure them. Okay? We just throw them on this cart. And I park this cart near this table, like it is now. someone comes along and it bumps this cart enough where this thing starts to fall. Could we easily see the end of this hit the vise or the table and bust this part off? I mean, that doesn't take much to happen, right? I mean, that's not like you have to really work that hard. That's where the balloon thing, it's gonna go. Okay, it's not gonna shoot in one direction, it's just gonna go. And it's gonna bust through these walls. I mean, it's no problem. Okay, this is just like a little missile now inside this room. We're all inside here with it. Imagine, again, if we had it controlled and we could go outside and bust this thing up and see how far it goes, that's fun. Imagining it when you're inside this room and that thing takes off, that's a whole different story. So when you're on your own, because I change the tanks and I do all that stuff, but you have to unchain these, you have to roll them off, you have to roll a new one on, and those times you can still have that happen. Sometimes I get real nervous when I'm driving down the road and I see an old beat up truck and you got some of this stuff in the back. It's like, man, I hope they did their job. I mean, it doesn't take much for something to happen. So just be aware of that there is a lot of pressure and things can happen. I will show you a video that Mythbusters did to show the power of the tank, because that's always been that myth. Will it really go? Like, is it just going to sit there? What's it going to do? And you hear a lot of stories out there, so it's hard to know what to believe. And then last thing on the oxygen is the cylinder valve must be completely opened and closed. That's very important on oxygen. The cylinder valve must be completely open or completely closed. Now, if I could slice this apart, so you could see inside here, like the guts of it, you would see like a ring at the top and a ring at the bottom of the valve. And as you crank that valve open, there's a middle section where nothing's sealed. Okay, it's just open. Gases can start to escape out of that valve. Okay, it's not until I get the valve completely open where that ring hits the top of the valve and then it seals itself. Okay, and when I close it, the same thing happens. Okay, in between it's open. Then when it gets to the bottom, that bottom ring tightens down and it seals it again. Okay, that's unique to the oxygen valve. So it's very important, again, when you do your performance test, that, okay, when I open this valve, I have to open it completely. And it's going to seem like forever. Okay, when I do the demo on this, it'll be like, oh my gosh, like it's not just a couple turns. It actually takes quite a while to actually get it all the way open, but you can't stop. People on their performance test will go so far and they'll stop, and then they don't pass the test because they didn't open it all the way or they didn't close it all the way. Questions on oxygen? All right, let's move forward to acetylene. Acetylene is an unstable gas when it's above 15 psi. And that would be the working pressure. So unstable gas when above 15 psi.